So we're going to prove the change of base formula for logarithms, which says that if we take the logarithm of some base a of a letter b, we could change the base to something else, like something we'll call c, and take the log of the original number, but log base c of the original base. And that becomes most important like when we like to specifically choose base 10. So like we could just rewrite this as log b over log a. It doesn't matter the base that you choose. So to get started, I'm just going to define a variable. I'm going to say that the letter x, whenever we see x, that's the same thing as log base a of b. Again, I'm trying to prove something about this, so I'm going to call this thing x. Now what that means is just rewriting that logarithmic statement as an exponent. This says that a to the power of x will give you b. Again, because the logarithm says, what would you put on a to get b? Well, it says that number is x. So a to the x is equal to b. Now, if I was solving this equation, a valid operation I can do to both sides is just take the logarithm of both sides. So I'm going to take the logarithm of both sides, but I'm going to choose a different base. I'm just going to choose some random base called c. I'm going to take that of the left side. I'm going to take the log of the same base, c, of the right side. So now I'm going to start solving for x, and as we note from other properties that we have in logarithms, if we have an exponent on our input value of the logarithm, what we can do with that exponent is slide it in front to be a multiplier. So I'm going to rewrite this left side as x times the log base c of a. We didn't change the right side, so that's still equal to the log base c of b. Now if I wanted to get x alone, I'm just going to rewrite x, so I'm going to divide both sides by log base c of a. So I have gotten x alone successfully. So it says x is log base c of b over log base c of a. And now here I've proved it though, because I said x is the same thing as log base a of b. So right here I could replace this with log base a of b. So we've successfully shown that instead of taking the log of b in some base a, I could take the log of b with the base of c and divide it by the log of a with that base of c. And what we're demonstrating here is I just chose c as a placeholder. I could have chosen c to be any number. I could have chosen it to be 1, 50, 10, e, so that this letter c can be replaced by whatever base you choose.